Good morning everyone, myself Audrija. Now I am going to present on the topic of the physical oceanography of the transport of floating marine debris. So this is the scenario today. So in the sea, we can see the more and more plastic pollution, most of them are the food wrappers, plastic bottles, plastic bags. So 8 million metric tons of plastic are dumped in the ocean. So these are the different physical processes like the large scale gyres, mesoscale and submesoscale eddies, open ocean stokes, drift, internal tides and other, which are now going to discuss in the next few slides. So plastic debris we can see in all the compartments in the ocean which are affecting the marine ecosystems. This wise the nature of plastic, why we can choose the plastic to understand the different processes. So these are one type of mutualistic relationship, like from these different processes we can know about the plastic, and from this plastic debris transport we can know about the different physical processes that are occurring in the ocean. So why we choose plastic here? Because of the long longevity in the ocean. So this floating plastic debris is a unit tracer which can distribute it along the coastline, shipping areas and all, which we can know in that. So what are the different processes is basically driving this plastic transport. So from here the rivers is coming, the river discharge, and these are the winds, waves, tides, currents are coming. Due to the stokes drifts also which are forming and which are accumulating and transporting the plastic debris here and there. So we are now discussing these processes one by one. So first of all we are coming to the large scale gyres. This large scale gyres are basically the most efficient way in transferring the plastic. So there are due to the equipment transport, it is basically creates two surface zones. One is a surface convergence zone and another is a surface divergence zone. We can see that in the surface convergence zone more and more plastic has got accumulated. So there are the 5 subtropical gyres. One is the Indian Ocean gyre, two are the Atlantic and two are the Pacific Ocean gyre. So the Pacific Ocean gyre is known as the garbage patches, as it is the large and this much large that the 99% of everything here is the plastic. So this large scale gyres is the major efficient way of transporting the plastic. Other than this, there are the mesoscale eddies. These are the slow rotating vortices, and these mesoscale eddies are formed then the fronds and filaments, and these fronds and filaments are then disintegrated into the submesoscale eddies, which are fast rotating vortices and are more efficient in transporting these plastic materials from one region to another. So other than that, there are the open ocean stokes drift. So what is the open ocean stokes drift? During its periodic motion, a particle floating on the free surface on a surface gravity wave experience a net drift velocity in the direction of the wave propagation. So what is basically a Stokes drift velocity? It is the difference between the average Lagrangian flow velocity and the average Eulerian flow velocity. Other than this, there are the internal tides by which effect we can see more and more plastic accumulation in the reefs, in the estuaries and in the river sides. So other than this, this is the Langmuir circulation. So what is this? This is the Langmuir circulation cell. We are seeing two different zones. One is the surface convergence zone and another is the divergence zone. We can see that when the two Langmuir cell is converged in this layer, we are seeing basically the plastic particles. Here the pink material is the plastic particles which gets accumulated in the surface convergence zone. So we can see this kind of things. This is basically known as wind rows. So due to the wind, due to the Langmuir cell direction, we can see this kind of row kind of alignment in the ocean. So this is known as the wind rows caused by the Langmuir circulation. And here a new term has come, that the planktonic organism also accumulate in the language circulation set, which can enhance the biofouling. So what is basically the biofouling? So suppose this is a ship contains of the hard materials. So different planktons, phytoplanktons and zooplanktons, algae, which gets accumulated in the ships, and the ship get disintegrated. So this kind of features is known as biofouling. So other than this language circulation, there is the vertical transport, that if we increase the sea surface stratification and if we increase the density of the ocean, how the vertical transport can help in the transport of the plastic materials in the ocean. Other than that, there is the ice formation. So we can see here very clearly, it is a photo of the Arctic ice. So we can see here that this is the plastic materials which gets freezed in the Arctic Ocean. So what is generally happened, the supercooled water coming to the polar region, and here is the ice which is formed with accumulating all the plastic particles, and the more and more saline water it is releasing in the marine water. So the marine water here in this portion, it gets more dense and coming to the lower portion of the soil, which we know in the simple language as a thermohaline circulation. So this ice formation and the coastal waves can help in accumulating and in transporting the different plastic particles. So here is the another phenomenon, that how the coastal waves and surface waves and the drift can help in the plastic transport in the beaches. So this is the uprush of the waves which accumulates in the ocean, and it is the backrush which when the wave gets back into the ocean. So in this manner, the more and more plastic materials gets accumulated in the beach and also in the estuaries. So how the plastic particles can sink from the ocean surface? There are the different processes, like the marine snow can sink, and also the birds can take the plastic materials to the land. Also the biofouling, which can also sink, which can get more and more heavy and can get sink into the ocean. Other than that, the long distance migration by the different marine ecosystem can also occur in the ocean. So how to investigate the plastic transport in the ocean? So we can do the different in situ measurement by going to the sea. Also we can take the sediments from the ocean and can do the laboratory experiment, that what percent of different microplastics are there in that part of sediment of that region. We can also use the thermal remote sensing and the radar active microwave and the passive microwave remote sensing in knowing that how remote sensing can also get some information about that portion of the sea which is impossible to measure by the in situ measurements. And we can also use the numerical simulations method to know about the plastic transport in the ocean. So it is the conclusion here. In concluding, we can say that the different physical processes can say about where the plastic materials will go, and from where it is to remove more and more to be sustainable for this marine ecosystems, and also from which region of the fishing zone is the most vulnerable, and it should be banned for human consumption, because the more fish we consume from that region, the more and more microplastic we are also consuming from that region. So in this particular study, they have not taken the IOD and so related upwelling, downwelling, and how this processes affects this plastic pollution in the ocean, and also the sea surface stratification, and also the climate change, how the future projections can help in knowing that which region is the most vulnerable for the marine ecosystem, can also be an expansion of the study. So these are the few references, and